Okay, so as you know that we have the exam on Thursday next week, I don't know, if you want you can work on your own or we can choose some problems from the book and go through them together. Which one you prefer?
We should go through some together.
Okay, so let us go through it some together. I think there are some problems. Let us. This is the topic. So I have already itemized what you need to study on Google Classroom. So of course, you should in principle know what is coming. But I have itemized, so you can check it out yourself on Google Classroom. Okay, so let us solve some problems. It seems some of them are nice problems. I don't know. I have this feeling. This is the topic of number bases. Yes. Okay, so let us review things and try to, I don't know, for example, let us start with this problem. Part 1. So we want to know which number is that. Okay, do you have another preference?
What?
Yes? What is?
Yeah, that B on that question is wrong. It's not correct. You can't write that as the x is not the same number. So there are two x's, but they're two different numbers. So it's not a correct question. But yeah.
But why shouldn't it be correct?
On B.
Yes.
Yeah.
Might be the digit repeats itself, and they are giving you the.
Oh, it becomes 142.
What?
It becomes 142.
Ah, okay.
So it's not actually.
Ah, you have already done that.
Yes.
Ah, okay. I didn't know about it. But let us choose this one, for example. So this is a number 10x3 in base 4 is supposed to be equal to 113 in base 8. Okay, and then we are supposed to find the digit x. Okay, so let me write it here on the board. So okay, the problem is I have 0 digit x, and then I have 3 base 4. So if you don't mind, let me write my own notation. Base 4, I write it like this, is supposed to be equal to 113 base 8. And then we are supposed to find x. So this type of questions you will probably get in the exam as well. It's a very simple standard question. Okay, so what should we do? We have to expand the given number in the given base. So I start from the rightmost digit, so I would write 3, and then I go to the next digit, so plus x, I multiply it by the first power of my base. Then I go to the next digit, multiply it by the second power of my base, and I go to the next digit. So this is just, I hope that you remember what we did here. So I'm just following those rules. And then I have this digit multiplied by the third power of the base. This is the expansion of this. I will do the same thing for the right-hand side. So I would write 3 plus 1 multiplied by the first power of my base plus this number 1 multiplied by the second power of my base. And then immediately you see that this is just simple an equation. Is a simple equation. This is x unknown. You solve and find it. Yes? So let us simplify. So this number is 64. This number is 0. This number is 3. So I have 67. This is 4 times x. On the right-hand side, this is 64. This is 8, which is 72, 75. Yes? And then I move this to the other side, which is how much? 8. And then, of course, x is 2. Is 2 acceptable? Yes. Because it appears in base 4. What is the maximum limit for x? 3. And that is on the safe zone. Yes? It's very simple. Is that clear? Okay, so now I don't know. Let us go to the another problem. Do you know what is the meaning of this this rectangle around that?
Maybe that's a harder question or something.
No, because the levels are probably based on numbers. Okay, let us take this to solve it to see how it works. But I think we might need calculators. Or let us see how it goes. I need to read the preface. Because sometimes you start solving the problem and then you realize they want to solve it using computer or something. Okay, anyway, so let us solve this problem. We are supposed to determine the digits x and y so that number x54 to the base 12 is equal to 24y4 to the base 7. Okay? Okay, that's the question. What do you think I will do? I hope that you can help me with calculations because, okay, I don't think it's very heavy, but let us just do that. The starting point is always clear. There's only one way to solve these problems, and that is usually starting from the definition of the base. So I will take the first digit plus second digit multiplied by the first power of the base. Do you remember this expansion? Yes? And then I go to the next one, x multiplied by 12 to the power of 2. This is this. That is by definition. And I will do the same thing here, but that would be a little bit unfortunate. The numbers become big. So I will take this 4, and then I will take the second one, multiplied by the first power of my base, and then take the next digit, which is 4, multiplied by the second power of my base, and then finally 2 multiplied by the third power of my base. Yes, that is just normal way. Let us simplify things. This is 144. So 144x. Let us calculate this in our head. Yes, this is 60 and this is 4. So that is good, not hard. 64. The right hand side is a little bit problematic, but let us calculate things, yes? So 4 times 7 to power 2 is 196, yes? And then 2 times 7 to the power of 3. 7 to the power of 3 becomes 300. Okay, so this becomes 686. And then I have a 4 at the very end. Okay? So I take this 4 with that one, it becomes 200. It added here, so it becomes 886. But that is not easy to do. So this becomes 7y. And then 886. Okay, I can move this to the other one. So I'm just buying time because I don't know exactly. So 7y. If I take this one and subtract it there, it becomes what? Plus 228. And unfortunately, nothing is simplified. Okay. We want to find x and y. But the problem is that I have two unknowns with one equation. But don't think in that way, because even though you have one equation, but you know something more about x and y. For example, x and y cannot be decimal numbers. And what is the maximum value for x? Because it appears into the base 12, the maximum threshold is 11. And on the other hand, the maximum threshold for y, because it appears in 7, it is 6. So that doesn't mean that I have a lot of options, But still, there are some options left. I don't know if they really mean it to solve this, because might be, how can we solve the problem, do you know? It is not a good idea if I want to test everything. Of course, this is also possible, that because there are finitely many things, we can test. But let us see if we can do better. So this is loud thinking, I don't know. So what we do, let us use congruency a little bit, be a little bit creative here. So let us see if I can use modular arithmetic to find this, okay? So then, of course, this is not congruency, this is equality. So I can write equality in any base that I like. So let me get rid of the y. So let me write this. I'm not sure this is going to work, but let us see. And I'm not sure that why they have called this level 2 problem in that case. Anyway, so let us, because this is equal to that, when two numbers are equal, they are congruent to any module that I desire. Okay, I will take the small one. So first of all, tell me, is it understandable for you? From here, I can go back here, not the other way around. Be careful, because if this is happening, definitely this is happening, but this does not go back. If this is the case, it doesn't necessarily mean these numbers are equal. But if the numbers are equal, they are also congruent to any module that I like. I have chosen 7 because I can reduce these numbers a lot. Okay? But now, let us take this as an exercise in modular arithmetic. Can you simplify things for me? This is E-level question now. Okay? How it connects there, hope I am on the right way of thinking. Okay, so what happens here? What can I write for 7? 0, because I am in that module. So get rid of it. What can I write for 822? Yeah, you don't need to even to bother to think very hard. You can write it 700 and plus 122, and then 122 is what? 140 minus 18, something like that. I don't know, I'm just writing it in this way. Is that understandable? Because this becomes 122. So now in module 7, this is gone. In module 7, this is also gone. And minus 18 in module 7 has a better name, is?
What?
Minus 18 in module 3 is? 3. In module 7 is 3. So it means that instead, so here it becomes 0y, here it becomes 3. You see, I don't need calculators. So that's the power of modular arithmetic. Okay, and then what can I write 144? This is extremely simple. Just 4, yes? And then what happens? This is totally gone. I want to find this. Yes or no? So I want to find an x, but either way, I have some limitations for x. It cannot go higher than 11. And on the other hand, I want to keep this. Okay, I can do a little bit better. Let me because I want to get rid of 4. Unfortunately, if you remember in modular arithmetic, the bad thing is that I cannot divide. Okay? I cannot divide. But I want to get rid of this 4. I want to isolate my x. What do you think? Instead of dividing, you have to multiply by some appropriate number so that it can simplify to 1. 5 is good. It simplifies to minus 1. 6, 7, 8, what? 35 is a big number, so I just want to make sure that, so yeah, okay, I don't need to worry. I just multiply by 5 and then by minus 5. Okay, I multiply by minus 5. It becomes what? I don't need to kill myself, okay? I just do it in 2 steps. I multiplied everything by minus 5, But minus 20 has a good name, module 7. What is that? It's 1. So I reached the goal. Yes, it becomes x. And then minus 15 has also a better name. Not a very good name, but it's better. 6. Yes? Okay, at least I have something very handy here. I don't know if they are thinking like this to solve the problem. We can check the fast later. But this is extremely simple now. Yes? I want a number, integer, which is congruent to 6 module 7 on the one hand. And on the other hand, I already know what are my choices. I would suspect 0 is not my choice, because if they write x there on the left, they don't mean it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11. 10, 11. I want to look for all possibilities that this works. So it means that x minus 6 should be a multiple of 7. So 1 does not work, 2 does not work, 3 does not work, 4 does not work, 5 does not work, 6 works or not? 6 works. 7 does not work, 8 does not work, 9, 10, 11. So that's 6. Okay, so x is 6. Of course, to be really careful, I told you that this is not reversible. So this means that if this is going to work, there is no guarantee it works. If it is going to work, x is 6. Okay, but does really 6 work? Yes, because you can put this back here, just use a simple calculation and find your y, and this is done. Okay, so you see, because I say to myself, if this is true, then this is true, and then x is 6. But there is no guarantee this is possible. Okay? But when you put this back there, it becomes 144 times 6 is 7y is plus 822. Okay, so I hope that everything is divisible by 7, is it? If that is not the case, we are in trouble.
No, this is not divisible, but that doesn't matter.
No, it matters.
Now you can just.
I want to find y.
Yeah.
If x is 6, and I put it back there.
Yeah, it is. It becomes 42.
Is it?
Yeah.
Yes. This 100, yes, it is divisible. So it means that anyway, I don't need to bother myself. Please, you can use your calculator to calculate this, and then divide it by 7. This will give you y. Can you tell me what y is? This is 600, 200. So this 844. Am I right?
No.
864.
64. Okay, good. And then minus 822, which is 2 and 4 divide. Yes. Oh, that is also 6. So y is also 6. Anyway, that's working. So I don't consider this, to be honest, level 2 problems, and I will not give you this type of questions in the exam. So I don't know what they have thought about. Yeah, I mean, yeah. But of course, I will not give you access to calculator. Yes, so I will not. I don't know how they have thought about this problem, because I don't consider it a simple problem. Yes, at least if the next question that I see here is considered to be level 3 problem, at least this also deserves a level 3 problem. Might be either I am doing it differently or thinking in a hard way.
But if you got a
They have
calculator.
like a square around the number. Maybe that.
No, you haven't you? By the way, this is your book. You should have read this preface right now, till now. Here, I actually didn't try to guess.
Yeah.
I tried to derive it. And the reason I was suspicious, because I did this kind of calculation a lot. This is called Diophantine equations. So you have more unknowns than your equation. Okay. And then, of course, I remember the trick from old days. So I just tried to reproduce that, and it works. So I didn't guess, I derived. But might be this means that use GeoGebra. Even if you want to use GeoGebra, how can I find this using GeoGebra? One way is to draw the line and see where it passes through a grid point, which is integer, which I don't think it is that easy, is it? Because these numbers are so big. So you can do that. You can draw the graph of this, but let me first see what this symbol mean. I don't know. How you want to guess those numbers here?
Well, the way I did it, I just found the multiple of 144 that was over 822, and I checked if that worked, and it did work.
Oh, so might be. So then we reduce it to level 2 problem.
Yeah, that could work.
So my brain is not working for those cases very good. So I try to solve the problems in its full generality. But you are right, because what is the maximum? What is the maximum level of the right hand side? So it cannot. So if I choose y to be 6, this is the maximum possible of the right hand side. Then I will try to play around. Okay. Anyway, which one you like, you can choose it. Okay. If you don't mind, let us try. This type of questions, I think this is a reasonable question for the exam. Yes? Because first of all, this is a higher level question because you have a connection between bases and modular arithmetic, and it is extremely simple to do it without calculator. Okay? So let us do this problem together. We are supposed to calculate 656 in the base 8 plus ABC in the base 16. I hope that you remember what is the meaning of ABC here when I'm working in base 16. We want to simplify it module 10. This is a reasonable question for the exam, okay? Okay, hopefully it worked, yes? So how should I do that? What is the answer?
The answer is
8. So let us check. So I want to simplify this number to the base, in module 10. I start simplifying this and this separately to save some, and then add them at the end. So let me start with this one, 6, 5, 6 to the base 8. I use the expansion formula, 6 plus 5 times the first power of my base plus 6 times the second power of my base. This is this number. I want to simplify it, module 10. So I have to put the good names for them. 6 is reasonably good name. Instead of 8, I prefer to put -2. And this module is so simple, so you don't need to be worried. So here I put -2. Yes, this is my choice. Of course, you can do it in your own way. So what the answer is, this is just 24, this is -10, and this is 6. 24 is 30, to the module 10, 30 is 0, 10 is also 0. So this is just simply 0. Okay? But for the next one, ABC, do you remember what is ABC? So we have the digits from 0, 1, 2, 3 up to 9, and then after that, if my base is bigger, I also need one digit, which is called 10, 1, 0. Another digit, 11, another digit. This is called A, this is called B, this is called C, and if you have more, you continue, D, E, etc. So I expand this, I take the first number plus the second number multiplied by the first power of my base plus the third number multiplied by the second power of my base. And I want to simplify it module 10, but before doing that, let me write what is C? C is 12 plus B is 11 and A is 10. And I want to simplify it module 10. So this is the simplest one. It is 0, 12 is 2, 11 is 1, 16 is 6. So the answer becomes 8. But my question mark is the sum of them. But again, as you said, it is still 8 because this was 0, this was 8, and when I add them, 8 plus 0 is 8. So yes, you're right. The question mark is 8. Okay? Okay, any questions? Yeah, always, this is also might be a good question. I don't like this, but... So you are supposed to just add them up as if you are working to the base 2. Not as if, really you are working in base 2. But the point is that I don't want, if I understand it correctly, you are not supposed to choose to go to base 10, calculate there, come back to base 2. Okay? This is of course possible. You can change all these numbers to base 10, add them up, it becomes a number, switch back to base 2. But can you find a way without going back and forth do it? So I want to wait for you so that I can write the problem here. Okay, so I have it on the board. Do you have any idea what to do? So let me give you some idea from just, for example, let us say I want to add 998 in just normal base, and then I want to add 99 to it, for example. Or let me make another 9 here. So how do you add them in just normal addition? Of course, not using calculator. So you add 8 and 9, it goes beyond your base. It is 17. So what you write 7 here, and then you put a 1 there. Yes? And then do the calculation. 1 plus 9 is 10. 10 plus 9 is 19. You keep the first digit and then write 1 up there. And then you would say 10 plus 19 is 19, and then you put 19 there. This is the way that you do it when you are working to the base 10. Here you are doing the same thing, but to the base 2. Okay? So here, when do I go beyond my base? When the sum goes above 10. Yes? But when I am working to the base 2, what happens? If I go above 2, I have to break it down. Yes? Or even 2 itself. Here, if this is 2, you will still break it down. 2 plus 8, 0, and then you put 1 on top. So if I reach to the limit of the base or above, I have to break it down. Okay, so can you tell me what happens if I add them up now? So 1 plus 0 plus 1. What is 1 plus 0 plus 1? In base 10 is 2. But we are working in base 2. So what is 2 in its own base?
1, 0.
1, 0. Is that right? Because 2 is 1, 0. If I ask you what is 1, 0 to the base 2, you say 0 plus 1 multiplied by the first power of my base, which becomes 2. So remember, in base 2, 1 in base 2 plus 1 in base 2 is not 2, it is 1, 0. Okay, so let us just do that. 1 plus 0 is 1, plus 1 is what? 1, 0. Exactly as before, I keep 0 here, but I put a 1 on top. And then 1 plus 0 plus 0 plus 1 is what again? 2. So 2 again means I put 0, I put 1 on top. And then 1 plus 1 is 2, plus 0 is 2. Again, it means 1, 0. So then it becomes 2, again 0, I put 1 there. Okay, tell me the last row, the last column. 1 plus 1 plus 1 plus 1. So what should I write?
1, 0, 0, 0.
1?
0, 0.
Why?
Because it's 4.
Yeah, so in 1 plus 1 is what?
2.
2 is 1, 0. 1, 0 plus another 1 is 1, 1. 1, 1 plus 1 is 1, 1 plus 1 is 0, 1 here. Yes? But you cannot write 2. 2 itself is also 1, 0. So this means 1, 0, 0. Yes? Understandable? Okay, let me analyze this problem. By the way, I don't know, have you ever thought about why this method works for adding numbers? So let us try to understand this problem a little bit better. I think it's a good idea. We can check our answer in the way. Because let us do it. So if I want to expand this number, what should I write? I start 1. Let me start from the right-hand side this time. 1. The next digit is 0 times 2 to power 1. The next digit is 1 times 2 to power 2. The next digit is 0 times 2 to power 3. The next digit is 1 times 2 to power 4. I don't want to calculate it. Be careful. The next number, this is 0. The next one is also 0. The next one is also 0. But this one is 1. This one is also 1. And finally, the last number, this is 1. This one is also 1. This one is 0. This one is also 0. And then this one is 1. Okay? I want you to feel what I have done is right. This is in base 10. So it is very familiar to you. Let us add them up. So you add these numbers, you are working in base 10. So what is the sum? Is 2. Okay? You start adding them up. You have 0, 2 to power 1, 0, 2 to power 1, 1, 2 to power 1. So in total, how many 2 to power 1s you have? Only 1. Yes? Go to the next one. 1, 2 to power 2, nothing, nothing. So when I add them, I have only 1, 2 to power 2. Yes? Then I go to the next one. How many 2 to power 3s I have? Nothing, 1, nothing. So I have 1. And how many 2 to power 4s I have? 3. Yes? So this is undeniable. This is the correct answer. But if I want to write it in base 2, I am not allowed to write 2. And that is exact. And I am not allowed to write 3. Okay? So what we do, instead of 2, I would say to myself, I have 1 2 and another 2. So this means that I have 2 2s. Yes, with nothing left here. But again, 2 to this 2 times 2 means 2 to power 2. I have 1 2 to power 2 here, another 2 to power 2 here, so it means that I have 2 2 to power 2, which is 2 to power 3. And then I have 1 to power 3 here, 1 to power 3 here, so it means that I have 2 to power 4. Yes, because it becomes 2 times 2 to power 3. And then I have 1 of them here, 3 of them here, so this becomes 4 times 2 to power 4, which becomes 2 to power 6. So this means that this number is nothing except 1 2 to power 6. So it means that I have 1 2 3 4 5 6 zeros, and then I have 1. Yes, because when you say that I have 2 to power 6, it means that you have 0 0 2 to power 1, 0 2 to power 2, 0 2 to power 3, 0 2 to power 4, 0 2 to power 5, and then just 1 2 to power 6. So this is 1 0 0 0 0 0 0. And that's that number. So if you want to understand it in a different way, this is one way you can understand it. Any questions? This problem. It's a good problem, I would say. Show that p squared minus 1 is divisible by 24 if p is a prime number greater than 3. It's a good problem. I mean, yeah, you need to have a good understanding of how to do that. I think this should be in the division algorithm one, or divisibility. It's a good problem because we don't know that much about prime numbers, but we guarantee that if P is a prime number except 2 and 3, if you raise any prime number except those to the power of 2 minus 1, it's always divisible by 24. Okay, so if you don't mind, let me wait a little bit for you to see how you think about the problem. Okay, let me give you a hint, because working with 24 is hard, but let me ask your opinion. How do you know a number is divisible by 6? How do you know that the number is divisible by 6? You know the rule for divisibility by 2, just to be even, and then you know the rule for divisibility by 3. What was that, do you remember? If you add the digits. But we do not have any particular rule for divisibility by 6, but we immediately can combine these two rules and understand if a number is divisible by 6 or not. How? No. You just invented a new rule. No. How do you know that a number is divisible by 6?
It's even on the
If it is divisible by 2 and 3 simultaneously, it is guaranteed to be divisible by 6. But let me ask you another question. If a number is divisible by 2 and divisible by 6, do you think it is divisible by 12, the product? The answer is no. The 6 itself. 6 is divisible by 6, it is divisible by 2, but it is not divisible by 12. The culprit here is because 6 and 2 have some factor in common. In the case of 2 and 3 and 6, 6 is a product, but 2 and 3, the GCD of 2 and 3 is 1. But here the GCD is 2, so it does not work. If I want to know the divisibility by 12, I check the divisibility by 3 and 4 if I have rules. This will work. A number is divisible by 12 if and only if it is divisible by 3 and 4. So if I want, I can write something like this. If a number A is divisible by B, and the number A is also divisible by C, and the GCD of B and C is 1, then you can say that A is also divisible by the product. And this is something we want to use for this problem. So here, instead of tackling to 24 directly, okay, try to break it down. So 24 can be written as 8 times 3. And 3 and 8 doesn't have any factor in common other than 1. So if I can prove that a number is divisible by 3 and 8, it means it is divisible by 24. But we can also break it even more. Yes? How? With the smaller pieces. So 24 is what? 2 times 3 times 4. Yes? And they don't have any factors in common. We say they are relatively prime. Relatively prime means that GCD is 1.
And with 4 is no.
Pardon?
Is that a property like relevant to numbers?
What do you mean? I don't understand your
We
question.
have 3 numbers now.
Yes.
2 and 4.
Our rule was for 2.
No, you can
Yes.
just expand it for 3. Okay? Anyway, so what I want you to do for this problem, let us just do it together. I don't want to prove it is divisible by 24 directly. I prove it is divisible by 2, it is divisible by 3, and it is divisible by 4. If I can show that, what are you saying, Rasmus?
But like the number 12
Yes.
is divisible. And number 12 is divisible by 3. It is divisible by 4.
Yes.
It is not divisible by 2. But it is not divisible by 24.
It has to be 8, it's not 4.
No, I wrote it wrong. Sorry. This is what?
Still has to be.
No, I want to 4. Sorry. No, 4 is also not working. So let me see. 24.
It only works with 3 and 8.
Yeah, 3 and 8. Yes, you are right. It doesn't work for 2 and 3 and 4. You know why I made this mistake? Because I solved it with 3 and 8 with the Natur students, and they said that in the book they have written 2 and 3 and 4.
Oh yeah.
And I actually solved it with 3 and 8. Okay, so you are right. Thank you for correcting me. Otherwise, I would have wrong, and then we have corrected it. So 2, 3, and 4 does not work. Why? Because 2 and 4 does not have that property. But can you check the answer why they have written it wrong? If that student was correct. Anyway, the correct one. Sorry, we prove with 3 and 8. Is there any other way? No. Okay, so that is very good that we realized 2, 3, and 4 does not work. Yes, and that was a very good example of yours. So that is 12. 12 is divisible by 2. It is divisible by 3. It is divisible by 4, but it is not divisible by 24. And the culprit there is because 2 and 4, GCD of 2 and 4 is not 1. Okay? If you can check the faucet, of course I will check it later. But let us try to solve it in a proper way. We have to prove that this is divisible by 3 and it is divisible by 8. If I can do that, then I am done. Divisible by 3, I don't think it poses a big problem. Why? Because if P, in general, when I write P has 3 different forms when it comes to 3. Either it is a multiple of 3, or a multiple of 3 plus 1, or a multiple of 3 plus 2. Okay? This is in general. But now I know something more. I know that P is a prime greater than 3. So P cannot be of this form. Because in that case it is not prime. When you say 3Q, it means it is a multiple of 3. The only multiple of 3 which is prime is 3, which is excluded in the problem. P is greater than 3. So this means that because P is prime, I don't have this possibility here. How many possibilities are left? 2. Either P should be 3. I am not claiming that every number of this type is prime. I am saying this prime is either of this form or of this form. Yes? Either this one or that one. But P2 minus 1, I can factorize it like this. Do you agree? Okay, I have 2 possibilities. If my P is of this form, then P minus 1 is a multiple of Q. Is a multiple of 3. Because if P is this, P minus 1 is 3Q. It means it is a multiple of 3. Okay? But if I am not lucky and P is of this form, then P plus 1 is a multiple of 3. Because P plus 1 becomes 3Q plus 3 and I factor the 3 out. So in any case, either P minus 1 is a multiple of 3 or P plus 1 is a multiple of 3. Okay? So this means that anyway, P squared minus 1 is a multiple of 3. Understandable? Okay. But for the case 8, then it is very boring if I want to write. Of course, it might be not boring. We can just do that. How many options I have? In principle, 8 options. But hopefully I can eliminate many of them and see what is left. This is one way. Let us do it in that way. I'm curious to see how it goes. So when I work with 8, I have 8Q, 8Q plus 1, 8Q plus 2, 8Q plus 3, 8Q plus 4, 8Q plus 5, 8Q plus 6, and finally 8Q plus 7. These are my only options, okay, for any natural number. But now I know this is prime. So let us eliminate some of them that doesn't work. Does this work? No. It's a multiple of 8. It cannot be prime. Does this work? No. It's an even number. This does not work. And this does not work. Okay? So the only options that I have available are these cases. Okay, let us check. I'm lazy to write, just listen to me. Okay, if P is of this form, I am done. Why? Because P minus 1 becomes 8Q. And I don't care about what is the rest. It is a multiple of 8. Agree with me or not? Are you with me? Yes. So this is working. What happens if I have 8Q plus 3? If I have 8Q plus 3 and I put it here, this becomes 8Q plus 2. The next one becomes 8Q plus 4. I factor a 2 from here and a 4 from there, and I have my factor of 8. Yes? So that also works. If I go to 8Q plus 5, the same idea will work. Because if it is 8Q plus 5, then it becomes 8Q plus 4 multiplied by 8Q plus 6. I have a factor of 2 here and a factor of 4 here. So again, it's a factor of 8. It's a multiple of 8. That also works. And hopefully this will also work. Do you think it works? Yes. Because if 8Q plus 7, then this one itself is a multiple of 8. 8Q plus 7 plus 1 becomes 8Q plus 8, and I factor an 8 out. So this is the power of division algorithm. But this is not the way I thought in the beginning. Okay? I wanted to solve it a better way. Okay? So this is good. It works. Okay? And now the better way is this. I don't need to go to work with 8. I can work with even and odd numbers. Okay? Or if you want, you can work with 4 only. So this is an experience you need to get. So let us work with even and odd numbers. This P is even or odd in this case. P is prime, greater than 3, definitely odd. So this means that this takes this form. Okay? And now what I want to calculate, I want to calculate P squared minus 1. Okay? Which is P minus 1, P plus 1. But what is P minus 1? Is 2Q. What is P plus 1? Is 2Q plus 2. I factor a 2 out, I get 4QQ plus 1. I have a factor of 4, I need a factor of 8. But do I have my factor of 8 now?
Yes.
Why?
Because either Q is.
Yes, because this product is even. Yes, Q times Q plus 1 is definitely even. Because one of them, because they are consecutive integers, one of them is even. And when it is even, this means this is 2m. And then I will have my factor of 8. This is much faster. Okay? So this number, P squared minus 1, is a multiple of 3. It was fairly simple to prove. And it is a multiple of 8. Either you choose that way, or you choose this way. Or if you want, you can choose multiple of 4. For example, let us solve this problem with 4. Then I have 4Q, 4Q plus 1, 4Q plus 2, and 4Q plus 3, yes? This is not acceptable because my number is prime. This is not acceptable because my number is prime. Yes? Okay, and then I have P minus 1, P plus 1. If my number is of this form, this becomes 4Q. This becomes 4Q plus 2. I factor a 2, I have my factor of 8. If this is my number, then this becomes 4Q plus 2, and this becomes 4Q plus 4. I factor a 4, a factor of 2, I already have my factor of 8. So you see, I want you to think, so you see this division algorithm, it seems a little bit stupid in the beginning, but it is extremely powerful. It seems that we are saying something trivial and formulated as division algorithm, but you see it's very, very powerful. So it is very important problem because we don't know anything about every prime number, but we know that every prime number to power 2 minus 1 is divisible by 24, except of course 2 and 3. Yes?
Me and Simon found in my opinion, like more effective solution, I guess. Working with, because we're working with 6, I guess, as the number. So if
Okay, 6. I mean, this is I would prefer. This is the most efficient way.
well,
We're
we
working
could-
with 2.
Yeah, well, we could do it entirely without. We don't need to check it again. You can only use 6, and you don't have to check it with any other number than a multiple of 6.
Okay, let us check.
So
If you okay for 6, we have yes, you are right. We don't have that much options. So that is 6 is a little bit unusual, but let us work. 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4. Yeah, many options are eliminated. You are right. 6q plus 5. Yes.
yeah, everything we could.
So this one is eliminated because it's a multiple of 6. It cannot be prime. This is even, eliminated. This is even, eliminated. So what is left?
3.
This one is also eliminated because it's a factor of 3. Yes, you are right. Only 2 options are left. Okay? And then what you are saying is that we have only this one. This does give you multiple of 8.
Well, we didn't do it. We didn't do the conjugate pattern even. So what?
Okay, but it doesn't matter. Let us take this one.
Okay.
This gives you 6q, and then this gives you 6q plus 2. What do you have as a factor here now?
Well,
You have a factor of 6 and a factor of 2, which is a factor of 12, not 8.
yeah, no, that's because our solution was rather different from this way of doing it.
Okay, just tell it.
Okay, so
It doesn't matter, of course.
Yeah, yeah. So instead of writing p squared minus 1 as a conjugate pattern, we just plugged 6 plus.
No, it doesn't matter.
What?
So you shouldn't even say that. It doesn't matter if you plug here or if you plug there,
Well,
because they are the same thing.
yes, but what happens if you if you plug it into the first one and then expand, that minus 1 will cancel with another 1. So it kind of does matter. Or well,
No,
if
it doesn't matter, but let us just do that.
Yeah.
If you want, I can put it here. It becomes 36q squared plus 12q
yeah, well,
plus 1, and 1 is gone.
Okay.
But still, you have multiple of 12.
so yeah, well,
That was the same thing. First of all, is it the same thing or
yes,
not?
sorry, yes,
Yeah, because they are equal.
yes, sorry, I'm confused.
Yes.
Yeah, and then you factorize a 12.
Yes, it's a factor of 12.
No, 12q. 12q. you
Yes. It's a multiple of 12. Then what?
factorize. No, you factorize a q out as well.
Okay.
Yeah.
So
and
you
then
factor a 12q, and
and
then you have
left.
3q plus 1.
Yeah, and then either q is even or it's odd.
Okay, so you are this is not a game 1 step.
What?
So
Well-
you are talking about q exactly as I did here. I'm saying that either q is even,
well,
the
this,
other.
this proves it's divisible by 24
No, but why?
because
Then you have to prove this is a multiple of 2.
yes, which is either it is or q is a multiple of 2.
Oh, that is more or less the same thing as I told you here.
Yes, but that's only for 8.
No?
That's
Okay, so you
this-
want
this
to
is
go
for
through the
24. Yeah, this is for 24, which proves the entire thing instantly. You don't have to.
Okay, so if q is even, I have my multiple. If
Yeah.
q is odd, then the next one is
Yes.
even. That's correct.
Yeah.
Yes, that's correct. Anyway, but I want you to understand that this division algorithm is actually powerful. Because when I wrote it, I said that, okay, any number can be written one of these forms. You might say, okay, why this is good? At least in this example, you understand that we know p squared minus 1 for any prime number that even we don't know what they are, it's divisible by 24. Okay, so that's a very good promise. Okay, I don't know what time is it. We have a little bit of time, so let us also do this one quickly. Show that 4 to the n minus 1 is a composite number for all positive numbers, Hiltals n greater than 1. Why do you think this number is a composite number? 4 to the n minus 1, it is claiming that if n is any natural number greater than 1, of course for 1 it doesn't work because it gives you 3 3's prime, not composite. Why do you think 4 to the power of n minus 1 should be a composite number? Always is this is claiming that this number always generates composite numbers. It means that it always generates non-prime numbers. Why is that?
For n is greater than 1.
N greater than 1. Yes. Because for 1 it generates 3. If I put 1 there, it becomes 3. And of course this is a prime. Except for that, You don't have even one single chance to get a prime number out of this formula. But why?
För att om det är P och K så måste det väl vara samma P på. Då kan det inte vara minus och plus. Eller?
Why? Okay, let us finish that because it is simple. Why? Why 4 to the power of n minus 1 is not prime if n is greater than 1? Yeah, this is extremely simple. Yeah, extremely simple. So you don't value conjugate rule, yes? This is 2 to the power of 2n minus 1. Do you agree? And now factorize it. So it is not a prime number, yes? So it becomes 2 to the power n minus 1, 2 to the power of n plus 1. If I can't factorize a number, this is not 1, this is not 1. So that is definitely a non-prime number, which is called composite number. As simple as that. So instead of 4, you write 2 to the power 2, so it becomes 2 to the power 2n. If you don't like it, of course, at this level, you should be very good in these things. But if you don't like it, you can write it as 2 to the power of n to the power of 2 minus 1 to the power of 2. Then I factorize it. And then because n is greater than 1, this is definitely greater than 1. That is also definitely greater than 1. So I am writing my number as a product of two numbers. Both of them are greater than 1. So that number cannot be a prime number by definition. And if it is not a prime number, it is an integer. It is a composite number. Okay, any questions? So that was easy actually. Thank you very much.